Welcome. I want to talk today about a brand new technology that Coval Molecular Coatings has developed with our chemist for asset protection. It's the new generation of coatings. We've gotten away from traditional paints and adhesive type varnishes and polyurethanes and those type of things. They've allowed a certain amount of protection and that technology could get to, and we've set that aside and gone another direction, and we're using molecular technology with nano-sized particles. We actually, on a molecular level, cross-link with the hydrogen and oxygen atoms of the surface and actually become the new surface. So you can take a poor performing surface that oxidizes or breaks down from corrosion and put a new surface over it and now make it a super surface. So we don't peel or flake off if it's prepared correctly, and it lasts and lasts and lasts. It doesn't break down in the sun. It's highly abrasive resistant. It's about 3/4 as hard as a diamond actually. It's natural quartz from the ground. It's just inorganic quartz. But what we've been able to do is we've been able to use it on a nano-size scale. And nano is strictly a size. It actually equates to 1/1,000,000th of a meter. And within nano-sizing, there's 1 to 100 in nano-size. We have our particles so tiny, we're down between 8 and 30, depending on whether it's a coating or a sealer. And how I like to equate that is over a surface, if you're trying to hide it or coat it with a traditional coating, would be like on a table, like putting dinner plates down, 12-inch round dinner plates. Everywhere where those dinner plates intersect, there's a void. And that's where dirt, moisture, and the beginning of the breakdown of that traditional old coating. With nano-sized pieces of quartz, we're actually like putting a layer of very fine beach sand over the surface. So every piece of sand can fit and touch each other, and there is no voids. So if you were to look under a micron microscope, for example, over a very high quality industrial paint or epoxy or polyurethane, it doesn't matter who makes it, what it is, you would see openings the size of big beach balls in it. If you were to look at ours under a micron microscope, you may see the size of a pinhead. So if you can imagine this big void with traditional coatings allowing everything to get in and start to break down the substrate versus trying to get through a pinhole, it's a major difference. And the other thing is we don't use adhesive type properties to hold our material in place. It actually cross-links with the hydrogen and oxygen atoms and becomes new or welded to it. Okay? And that's the main difference between our technology and the traditional technology that was used before. This gives us leaps ahead. And with that technology, we're now allowed and able to coat things that other traditional coatings couldn't ever coat before. And so now we've opened up new avenues: glass, fabric, circuitry, marine and hull without even damaging or hurting the waterways, protecting the environment. You know, we talk about protecting assets, which is very important. Our historic buildings, you know, they're only going to last so long. We can't pass those on to the next generations unless we start preserving them now. They just won't hold up. So with our sealers, it doesn't change the look of the building. You don't know it's there. It's invisible, all right? But now we prevent that moisture and the environmental toxins that start breaking it down. We've now put this barrier that's invisible, you know, available and invisible, which is very, very cool. Our coatings are visual. They are coating. You do see them on the surface. Talking about our coatings. Now our coatings are very, very unique in that they make a new surface on a molecular level. So again, we take and we cross-link the coating with the atoms of the surface itself and become a new surface. For example, this piece of copper, when oxygen hits it, it oxidizes. This half has been coated. It's very, very thin. You can't even get your fingernail in it. It's about 2 microns thick. It's also extremely durable. You can put our coating, so if you have something that's metal, you use our metal coat. If you have something that's concrete, use our concrete coat. If you have circuitry, you use our circuit coat. If you have wood, you use our wood coat. If you have stone, you use our stone coat. So each one, if you have a graffiti issue on a sign, you use our anti-graffiti coat. So everything is titled for what it protects. Vinyl floor coat. This replaces wax. You don't have to wax anymore. And it can go on any type of metal. This is painted. This is brass. This is galvanized. This is aluminum. This is stainless steel. And this is regular steel. Now what we've done here is, obviously this side has been coated, but we poured acid over this surface and it destroyed the non-coated. And you can see there's a very distinct difference. Okay? Coated, uncoated. So you want to talk about maximum protection of iron and steel. This gives you that maximum protection. Actually works better than galvanization, chrome conversion, anodization. It works better than all of those in lab tests. Okay? Now what I want to do, if Lisa, if you can bring over some food items that you would normally find in your kitchen. A lot of people want to have marble countertops, or there's marble tables in restaurants or marble bars. The problem with marble is that it's calcium based, and what happens when these acidic items that you see in front of you come in contact with the calcium, they immediately stain or etch the surface. Now we've put our stone coat on here. It is a coating. You can very barely see it. It is visible. But now I can even write on it with a permanent marker and it won't bleed through. Okay? And Lisa's going to pour some, or hand me some red wine. This is a nice Merlot. So we're going to put a little red wine on here. Normally, you pour red wine on white marble. Not only the acidity in the wine will etch it, it will also stain. Ketchup is highly acidic and stains also, so we'll put a little ketchup on here. And we have some balsamic vinegar and some lemon juice. Lemon juice, probably the worst thing you can do. This is balsamic vinegar. People use this in their salads all the time. Again, immediately will stain and etch the surface. We'll put a little bit of that. And oil, you know, the oil in here, oils just want to stain everything. And then lemon juice. Now lemon juice is highly acidic. If I were to put it on a piece of marble that didn't have the coating, if I just poured it like this and immediately wiped it up, it would be too late. It'll happen in less than 1 second. But what we're going to do during this presentation is we're just going to let all that sit there. Because the biggest problem people think is, oh, if I clean it up right away, I'm saved. You're not. But we're just going to let this sit here for quite a while. Okay? So we have permanent marker, red wine, ketchup, balsamic vinegar, and lemon juice. And we'll let it sit. What we talked about is how we create this super tight structure, right? This molecular structure that grows over the surface and actually becomes the new surface. We talked earlier about traditional paints and coatings under a microscope have large beach ball sized holes, and ours has maybe a pinhole. Again, the analogy of dinner plates covering a surface or sand. The sand, everything can fit together. A good way to illustrate that is here I have a piece of powder coated metal. One side is traditional powder coating. It looks like it's completely covered, 100%. You cannot see any voids. On this half, we put our metal coat over the top of it. And what I'm going to do for it, you can see I've done this a few times, is I'm going to take a permanent marker, which when they described it as a permanent marker, they didn't know about Coval molecular coatings because it's not permanent on here. And what's happening right now, because we've created this tight molecular structure here, this permanent marker is unable to bleed through the surface. Where on the powder coated side, which is a good standard, everybody's been using powder coating for years, it works pretty good, but it doesn't hold up near to what we can do. So if this permanent marker gets through, you can imagine everything else is getting through it, okay? And here on this side. And now all I got to do, even if I were to write on the copper, anything that's coated, I can put the permanent marker. Even on signage, we'll do that. concrete, we did it on the marble. Even on grout, here's tile. This has our concrete coat. If you were to put permanent marker on grout, which is very porous, it would bleed through. We're going to go ahead and coat the grout. Vinyl flooring, for example, permanently would be there without it. Here we have it on our metals. Here's on stainless steel. And look how nice the stainless steel looks. See the fingerprints and so forth on the uncoated side, where this side doesn't have anything, any marks. Aluminum. Look how bad this aluminum looks on this side. This side, same piece, handled just as many times. Okay. Galvanized, the same thing. It's hard to tell if there's any difference. But PV brass is a common, PV coatings are very common to protect brass. This side has our coating. This has been traveled around the world, demonstrated everywhere. You can see how this is already breaking down and getting destroyed. If I turn this over, you can see the uncoated PV versus the coated with our Coval metal coat. This is 3 or 4 years old right now, and it's still perfect and pristine shape. Okay? So now we've created these, what we believe are permanent stains with the marker, right? You can get a majority of the stain out using chemicals, okay? But it still has bled through. You're only going to get about 95%. It will leave a shadow behind. What I'm going to do is I'm just going to take this floor sponge and I'm going to go over to the sink behind me and just get it wet with water. And the reason I'm going to do it out of the faucet is you can see for sure that it's just water and not a chemical. Okay, right here on the copper, 100% gone, no scrubbing necessary. Okay. Here on this piece of metal, okay, came right off on that side. Now this side, you can still see that line. I could get the surface part off, but it still bled through. So it's 100% gone here. Here on the vinyl floor. What's nice about vinyl floor is it's the least expensive floor to put in, but it's the #1 most expensive floor to maintain. Because in a public area, you see them in a lot of administrative buildings and so forth, they have to wax it once or twice a month, burnish and wax it. Once you put this on, you don't need to do that. We've been on hotel lobbies for a year now, they've never had to wax them again. I'm just going to take, and the other thing that's, see how that came off? Instantly, okay? Concrete counter. Gone. This piece of aluminum, aluminum's pretty porous, just came right off. Over the stainless steel, super, super easy. Now, what about signs? Okay, the problem with signs is when you try to clean them after they've been graffitied, the cleaners don't know what's to stay and what's to go. So you spray paint this or write on with permanent marker and they're going to come by with a chemical cleaner. So we're going to do that to show you that the chemical, and I'm just using a little light soy, but I just want you to see that the letters are now preserved, okay? So we're just going to spray a little bit on here, and the only thing that's wiping off is actually the permanent marker. The letters are fine. So now you don't have to throw the sign away. The amount of money that can be saved, every time it gets tagged, you nearly wipe it off, okay? And you can use a chemical to wipe it off. In a bathroom, you know, they're going to come in there with bath cleaner and stuff. So once again, I'll just spray a little chemical on here, which is just soy. Do you see it just running off now? That's on grout. Grout is very, very porous. It just wicks it up. So it's great in public restrooms where you get uric acid and so forth migrating. You have that smell all the time because it gets into the pores and stays. Now you can put the coating on there and it'll just clean off the surface. Okay. Here we have on our piece of marble, the permanent marker. I just wiped it right off. If we were to wipe it off on a piece of marble that didn't have it, which is on the back side, I'll show you, we can't get it off, even using a chemical. Okay? So again, how this works is it creates that super, super tight structure. So again, we've had this sitting on for quite some time. I'm just going to take a paper towel. So here we have a typical highway sign. Right now, they're going to this diamond prism reflective backing. And the color they use now is ink. So this sign was brand new, and the California Department of Transportation tried several different coatings to protect this, including ours. So this upper quadrant here is our anti-graffiti coat. The other areas were other competitors, and they tagged the sign and they tried to clean it. Okay? In that process, the sign was destroyed, other than this area right here. This breach right here was full strength sulfuric acid for 24 hours. So it's not impervious to that type of damage, but to normal graffiti, wear and tear. So a sign like this costs about $100. The coating costs a couple dollars. So this sign can be cleaned and cleaned and cleaned. So every time it gets tagged, they save $100. So for highway departments, cities, counties, municipalities that are in charge of paying for and replacing signs that are damaged, they just put this on one time. Their maintenance crews can go in and very easily, you see how easily permanent marker comes off. Paint, you would need some type of solvent to break it down, a mild cleaner. We have cleaners that work very effectively on this without damaging it. Is we have a quick seal and an enhance. And what that does, when I mean quick seal, I mean quick. In 1 minute, the surface after it's been applied is dry and water resistant. With traditional sealers, you can't do that. If they were to get wet before they cured, they would turn white because they contain acrylic. We don't contain any acrylic in ours. And so it doesn't break down in the sun, it doesn't turn white when it gets wet. And the other unique thing about it is we can add stain to it. And what we've done is add a stain, and you put it right into the sealer. So you seal and stain in one step. With traditional staining methods, you seal it, then you stain it, then you top coat it. With ours, you seal and stain in one step, and then you can top coat it, which we've done here. But the most unique thing, as I said, is that it's dry almost immediately. What I'm going to do for you right now is just show you on a piece of slate. Let's remove the lid. Goes on clear. The best way to apply this is with a pump sprayer, but it just adds a very nice natural look. And we're going to time this for you right now. I've finished my application, and we're going to go 1 minute. It will be completely dry to where we can pour water on it. And again, there's nothing that we're aware of
Move your hand.
that has this capability. This is about 20 VOC, so again, very, very low, very, very, very environmentally friendly. It's perfect for when you do large areas that are open to the public that you can't close down for days with traditional sealers. Again, you can do an area, clean up the mess, and open it up 5 minutes later to the public, and they won't ruin it. The other thing about it is it's very natural looking in its enhancement. As you can see, it doesn't look like a heavy lacquer or anything else that's been put on. It just brought out the color of this natural stone. Okay, so we've just completed 1 minute, as you can see in the timer. You can touch it, completely dry. And now I'm going to pour water on this. Now, if this were a traditional sealer, it would turn white or it would soak in. Now we're going to go on the unsealed side to let you know how porous it is. That just soaked right in. You see that? And now if I turn this around the other way and try to make the water, look how it wants to stop at that edge. See how much I'm tilting it? See how it just beads off? Can you imagine how clean, like Tiananmen Square or High Public Area, if it rains and the water slides off that easily, it's just going to carry the dirt with it. Okay? So we'll just do this. And again, it's completely dry. Concrete today is one of the most common building products. Tilt-up buildings, high-rises, glass concrete. That's all you see. Sidewalks, roadways, bridges, overpasses. But concrete is very, very, very porous. So it wants to wick the moisture in like a sponge. And if you're in a coastal region, you're also introducing the salt fog from the coastal area. And that salt travels through the concrete with the moisture. Okay? And inside that concrete is all the steel reinforcing metals that hold the concrete together. Concrete itself is not structural. You need concrete to be held in place and give it structural integrity with rebar. Now, the rebar is made of steel. So if you take the steel and you put salt water on it, it corrodes it, rusts it. Then it expands and cracks. Now you've cracked that concrete and you've created an additional expedited path for that moisture to get through because you're now cracking and spalling the concrete. And so this piece of concrete in front of you has been tested for years now. This is probably 3 or 4 years old. You can see a difference in appearance. When this started off, it looked the same. This side is sealed, this isn't. But I've done this so many times that the water is actually damaging the concrete just from the demos. And again, we'll just point out, this is breathable. It's just a water repellent. It's not waterproof. You will get a very little bit of moisture, but it's not migrating through the surface. And doing a little water test will demonstrate that for you. So I'll just put this at a bit of an angle so you can see. And see, a very definitive line. This is, again, all look the same, but now this moisture is just running off. And see how quickly it wicks into the concrete? That's going through the concrete at a very fast speed and is now approaching and hitting that rebar and causing the rebar to rust. So we quickly lose the strength of our
Perfect. You'd like fan it out a little bit with both hands? Nice.
The thing about our metal coat, which is very unique, is we can actually add stain to it and transform an inexpensive metal into something that looks like brass or copper or any other. We have 21 vibrant colors. And so what I have here is just a piece of stainless steel, okay? And I've added our copper stain to the metal coat. So when I coated the metal, I ended up getting a piece of copper. So outside furniture, you can use an inexpensive metal and make beautiful copper furniture that would actually hold up better than stainless steel furniture. Okay? It works on any kind of metal. For example, this is a piece of aluminum, and I've added bronze color to this. So I'm going to turn this over, and now we have this beautiful bronze color. Okay? So now we've gone with aluminum. Here, this has the metal coat. The colors are very vibrant. Here again, a piece of aluminum. We've added the red stain to it. and we have this beautiful red. Again, simple piece, boring aluminum, transform it. This is with the blue. And you could add or subtract the amount of stain to get the color darker or lighter. You could also blend the stain colors and create a whole array of new colors. Okay? This is just a small sampling. Look how beautiful this is. This is our mink. So again, companies doing outside lighting fixtures, garden lighting fixtures, chaise lounges, pool furniture, so forth. Can you imagine having a color that was painted outside in a pool with chlorine and salt and so forth? It wouldn't last one season. Now you can take and coat it, last season after season after season. And we do have quite a few resorts around the world that are starting to use that. Again, just simple gray piece of aluminum, beautiful violet color. Copper, lemon. Again, there's 21 colors. We're showing you just a few selective samples today. Okay. The unique thing about our metal coat too is that it's not combustible. I've taken a piece of stainless steel and we've coated it with the metal coat. Then we applied a propane torch with air at 1,945 degrees directly onto the surface. We could not get it to catch fire. The coating was breached at that temperature, but it didn't burn, it didn't catch the coating on fire. This area here, you can see the coating is still there, and to prove that is I'll write on it with a permanent marker, and we know that permanent marker will bleed through any surface. I'll let that just sit there a second. I'll get my sponge and I'll just wipe it off. So again, this is stainless. We basically destroyed the stainless, but the coating did stay intact where we didn't burn it off. This would be ideal for kitchen hoods, where grease and so forth wants to stick to it. Makes it a lot tighter surface, smoother surface, easier to clean. And if there were a kitchen fire, it's not going to combust. And again, I just take the sponge. Today we're going to show you how protective the coating is, the metal coat, concrete coat, so forth. I have here a little bit of muriatic acid, very corrosive. And what I want to show you is that the environment, the acid rains, pollution, chemical plants, that type of thing, just corrodes the metal. Any factory setting, you have these acidic gases in the air, and they just start corroding everything. Also salt fog around coastal regions and so forth. To expedite the corrosion process, I'm going to put some acid on here to show you the areas that are coated are unaffected by this harsh chemical. Now, I'm going to pour it on this side right here that's unprotected on aluminum. All right, so you can see that it's starting to eat away the surface there. What I'll do is I'll just roll it across to the other side here. See, actually, it doesn't even want to go near it. So we'll put the acid on that side. Can you see how it's burned the aluminum? Very definitive line. Okay. Now we're going to put it on the steel. See how it's turning white? It's corroding. It's actually eating away the rust. I mean, that's one of the reasons how they clean rust. And we're going to put it on this side that has the coating. And it'll actually look just like water on here because there's no chemical reaction. Can you see how clear that is? And see how it actually ate the rust off? See that, how it cleans the rust?
Oh, wow.
Okay, but this side, there's no change. It burned all the aluminum, and this side, nothing. But if I wipe it off those areas, can you see how it etched through the aluminum? Actually got that. Here on the steel, it's fine. Here on the steel, actually ate through the rust and cleaned the rust off.